This is a review of the year in space for 2022. We'll start with getting into space by the numbers. 2022 was really a record year. If you look down this page, there were a total of 186 launches this year. 179 of those were successful. That compares to much less the previous year, 125, 134 total launches, 125 successful, and up from 114 launches the year before. The U.S. was the leader, as usually happens here. There were a total of 87 launches, of which 85 were successful. And again, that is a giant leap from the 48 and 51 launches the previous year. China comes in second. They launched 64 times and 62 times were successful. Again, up from 48 launches and 39 in the previous years. Russia held more constant, 22 launches and successes, pretty much the same as the previous year. Those are the big three. And then there's a huge drop down to the next tier. Europe, as usual, comes in with just a few launches. They had 5 total, of which 4 were successful. And that's been pretty consistent over the last 3 years. India is actually matching Europe exactly. 5 launches, of which 4 were successful. Then we're down to Japan, which had nothing this year compared to a couple last year. South Korea had 1, Israel didn't have any. Iran had 1 launch and 1 success. Now, the interesting thing here is that SpaceX alone launched 61 times and succeeded all those times. They had no failures. 60 of those 61 were on the Falcon 9. 1 of those was on the Falcon Heavy. Now, 34 of those launches, more than half, were for their own internal project for internet called Starlink. That was 34 launches. But even without those 34 launches, SpaceX was clearly leading the pack here. So once again, we exceeded all the records, and that's pretty much it. These numbers are pretty widely agreed on. The failure counts may vary slightly, in particular because of Firefly, which was a new launcher this year. They put a bunch of satellites up into orbit, so they claimed success, and I gave them credit for success here. But the reality is, it wasn't quite a high enough orbit, and there's too much air friction, and a week later they fell out of the sky. So there's some room for variations in some of these numbers. A big story this year was the James Webb Space Telescope. Now, this was an infrared space telescope orbiting the sun, actually at the Earth's sun L2 point, so that it matches the rotation of the Earth around the sun. It was launched back in December 2021 on Christmas Day, but then, of course, deployment occurred over the following months. The first images finally started coming back this year, and they were terrific, as good as theoretically possible, in fact. They had some minor hits from micrometeorites. One of them was bigger than they really had planned for, but in general, they had expected that and built the craft to be fairly robust to any kind of hits by micrometeorites, because they're always out there. This was also a good year for testing for planetary defense. The big story was the DART spacecraft, which crashed into an asteroid on September 26. That was on purpose. The idea was to change its orbit. And we have now proved that we can successfully hit and change an asteroid's orbit. So that's important in being able to defend Earth in the future. Another story, though, that didn't get as much attention was that the NEO Surveyor, stands for Near Earth Object, that's been revived. It was a project to put an infrared space telescope in place to detect dangerous asteroids and comets, the kind that can knock out cities. And it had been kind of asked for by Congress, but was never really properly funded. Finally, funding and everything is now in place, and this project is a go. There were other milestones in the deep space exploration category. The Lucy asteroid mission, which is going to visit asteroids near Jupiter, it did continue. It had some problems. There was a solar array, which you can see in the picture in the upper right here, didn't quite close. It goes out as a fan and is supposed to lock in place in a complete circle. Didn't quite make it. They finally concluded that they got it close enough that it won't cause too many problems, and it's a go. Another probe is the Juno probe. It passed within 220 miles of Jupiter's moon Europa back on September 29th. And there's a picture here. There's a sample about 100 miles wide. Good close-up of the crust. Another solar probe that's out there is called the Parker Solar Probe, and it's done what is called touching the sun, meaning it goes into the sun's corona. It's now done that 4 times, just spiraling inward, getting it closer and closer to the sun over time, and it did it 4 times in 2022. Mars exploration continued during 2022. There were some notable events. India had a Mars orbiter and it exhausted its propellant. As a result, it couldn't avoid an eclipse of the sun by Mars that lasted quite a while, 8 or 9 hours. And it ended up dying of power loss and subsequent battery failure. And again, that was about 8 years, so it was a good life. There are plenty of other orbiters that are still going strong, however, 3 from the United States, 2 from Europe, 1 from the United Arab Emirates, and 1 from China. The one from China is the one that dropped off its own rover on the ground. Another event was the InSight lander. This was from the US. Its solar cells got covered with dust, and it's been declared dead. It's just been struggling over time. The power output of the solar cells went down and down and down. There just wasn't enough wind in this big flat area near the equator where InSight landed. So after 4 years and 19 days, it was declared dead. It did succeed. It lived beyond its stated life in any case, and analyzed a lot of Mars quakes, found one of the biggest ones they'd ever seen at category 5. Its real purpose was to analyze the planet's interior structure, and that's why it landed in a big, flat, boring area. It didn't care about the local area, it cared about the interior. So it found out the size of the molten core inside of Mars and other things. As far as rovers on the ground, they're going strong. There's 3 of them. The Perseverance, the most recent US one, and Curiosity, the one that's been there for 8 or 9 years already. And then the Chinese one, Tianwen. They're all going strong. Perseverance started depositing samples. They've been taking samples, and now they're leaving them on the ground for what's hoped to be retrieval sometime in the future from a Mars sample return project. The Ingenuity helicopter that was a part of the Perseverance rover, it set some new altitude records. It flew up to a height of 46 feet in its 35th flight. So it's doing quite well. The moon is becoming a big focus of activity. Artemis is the overall program for going to the moon, which is part of the overall effort, Moon to Mars, which includes getting to Mars. Moon first, then Mars. The capstone launch is a part of the Artemis program. That was a CubeSat, a small one. Was launched on June 28th on Electron rocket, which is a really very small rocket. But it went to the moon. It was designed to test the orbit for a future lunar space station called Gateway. And it arrived in lunar orbit on November 14th. So it took a very long time to get there, but that was okay because you could do it on a small rocket. The Commercial Lunar Payload Services, or CLPS program, is a project by NASA to have a whole variety of missions funded in small quantities with lots of experimentation. Most of those got delayed. They're robotic lunar explorers, but that means that 2023 will have a lot of these. The big story, though, is Artemis 1, the big SLS rocket plus the Orion capsule. That was finally launched after many, many years in an uncrewed test on November 16th. And it was quite successful. The idea was to send the Orion capsule around the moon and returning it to Earth. It came back and splashed down on December 11th. So that was quite a success. Now, there were also some ride shares, that is secondary payloads, that were included as part of this. There were orbiters that were going to be orbiting the moon, and some were going off to orbit the sun. And there was even going to be a lunar lander as part of this. Japanese Space Agency had a very small lander, about 31 pounds. And the idea was to drop it down there. It had a big airbag so that it didn't have to land too softly. Unfortunately, somewhere between 4 and 6 of these 10 ride shares did fail. Some of that has really been blamed on the long delays in Artemis, and as a result, many of these batteries, which are rechargeable on these spacecraft, they ran down. They couldn't all be recharged, and some of that was probably a cause for failures. Notable failures included one mission to an asteroid, which was going to use a solar sail. And another one was, of course, this Japanese lander. There were 2 other lunar launches this year. South Korea got their first lunar orbiter up there. It was launched on August 4th on a Falcon 9 and arrived December 16th. So that's on a very long time period to get there, but the trade-off is there's ways to do it that take very little energy. Second launch was on a Falcon 9 on December 11th, and it had two major parts to it. One is a project called the Lunar Flashlight from NASA, and its idea is to survey water ice in the craters of the moon. It uses infrared lasers to do that. The idea is to support future in situ resource utilization. That is, live off the fat of the land. In this case, find water. First, you have to find it with this prospector kind of project. Then you figure out how to get the water and use it. One notable feature of this particular craft is that it also used a new monopropellant, which is intended to replace hydrazine. Hydrazine is very, very toxic. It's typically been used in the past. And this one is not so toxic and is actually more efficient. Monopropellant simply means that you don't need to combine two chemicals. You just have the one propellant, it hits a catalyst, and you get your thrust. The second part of this Falcon 9 launch was a private mission, the Kudo Mission 1 lunar lander. This is from iSpace, a Japanese private company who intends to make a business out of delivering loads to the moon. And it was the first private one. It's shown here in the center of this. It includes then, once it lands, it includes several small payloads, one of which is another rover. This one built and designed by the United Arab Emirates. So that's shown on the right-hand side here. The left-hand side showed this lunar flashlight from NASA. This was a year when China announced much more aggressive plans for the moon. They had previous plans for lunar bases and many robotic missions. They moved them all up by 8 years in some cases. So they will have both robotic and manned missions. They'll have a base, as shown here in this diagram, and lots of other missions, in particular focusing on the same areas the U.S. wants to go to, like the South Pole, which is quite strategic because you can get sunlight there most of the time, and there's water hidden in the craters there. So the real question is going to be, in fact, can the U.S. really catch up with the Chinese on the moon's surface? The Chinese have a huge lead here. They have put down rovers on the far side of the moon. The U.S. has never even landed a rover at all. They have a satellite for communicating with their rover on the back of the moon, and they've done sample returns, robotic sample returns from the moon back to Earth. Again, the U.S. has not done any of these things in the past, so we're definitely in a catch-up mode here. I think there's a good chance we will catch up because of all the activity going on. In particular, in 2023, there are a lot of landers, and this should get very, very interesting. The Ukraine war has had a huge impact on the world economy, and it has disrupted business in space as well. The West, which I include Japan, Korea, and Taiwan, they're dropping Russian business. We just needed to take a stand. Europe had a very heavy dependence on Russian launches. They've really had to change a lot of their plans. It stopped a lot of science missions like ExoMars, a lot of exploration, even commercial launches. Even some spy satellites, for instance, French and I think some Germans have actually launched spy satellites for their own military using Russian launchers. Well, that's not happening anymore. The satellite constellation builders are also heavily impacted by this. They're scrambling to get new launchers. And in particular, the people that are still putting up a lot of satellites besides SpaceX include OneWeb, internet service, and the Kuiper project from Amazon, which also needs a huge number of satellites. What's ended up happening is that this just solidified the dominance of SpaceX for launch, for anything medium and heavy, mainly by removing the major competitor, which was Russia, with their Soyuz craft. Nobody wants to use that anymore. But this also has caused massive funding for SpaceX's future competition, because OneWeb is a competitor with SpaceX and Starlink. Kuiper is certainly a competitor. And of course, there's also personal animosity between Bezos and Musk. So they weren't going to spend money on SpaceX. And that result is that there is a lot of funding that's going to the competition for SpaceX in the future. Another big effect of the Ukraine war has been a vast increase in commercial satellite use. There have been a lot of mostly low Earth orbit satellite constellations that have grown up. They're used for spying. I mean, the Earth observation satellites are picking up, Russian troop movements and that sort of thing, and also military communications, in particular, as used in Ukraine. They've been using Starlink. One side effect of all this, though, is that now these providers of services, like SpaceX with their Starlink and so on, they're more at risk because Russia may at some point decide to try to take out some of that satellite capacity. They've said it quite explicitly that they are, possible targets. And it doesn't necessarily have to be kinetic impact, by blasting something and blowing it up. Everybody has capabilities for blinding satellites with lasers and so on. So there's a big concern, really, on everybody's part as to what's going to happen. But the military is definitely using more and more of the commercial satellites for the spy sort of use as well as communications. The Ukrainian aerospace industry was pretty much demolished, literally. This had a bigger effect than most people expected. The Antares rocket, which has been used for the space station cargo deliveries, and would have been used more in the future. That whole first stage was built in Ukraine, and it used Russian engines. So that's of course out the window now. They're replacing that. Antares is now going to use Firefly engines, but that'll take a while before they make that transition. The Europeans had the Vega rocket, the Vega C rocket, that also had Ukrainian involvement, and again, that's all gone now. So there's some pictures here of some of these affected projects. The Antares rocket I talked about. ESA's science projects like the ExoMars project, where they're going to put a rover on Mars, that obviously got messed up because the Russians were the ones delivering it. And then there's an example in this case of Maxar having satellites that are that are being used to monitor Earth and troop movements and so on. The International Space Station is still going strong. It's increasing its age, and there's an end of life in sight. But if anything, activities have probably picked up, and the main reason for that is simply that it's easier and cheaper access now thanks to SpaceX. We can get the crew and the cargo up there, and more experiments can actually be done. Now, the Russians are still cooperating, which is somewhat of a surprise given that they're not cooperating on anything else. But there was enough concern that the biggest concern is that they maintain the orbit. They do literally the heavy lifting, keeping the orbit of the spacecraft, the whole space station. We have minor controls, but they do the bulk of the work, both on their own thrusters on the station and in particular on the Soyuz spacecraft. So instead, what we've done is a little bit of testing with the Antares to see if we can at least do some boosts on our own. So we tested that. And that at least provides some short-term breathing space. That doesn't work out long-term because the Antares rocket has to be changed out because it had the Russian engines. But eventually, that'll all get worked out. It was also a big year in that this was the first human mission to the ISS that was all commercial, called Axiom 1. That happened this year. There are a variety of problems associated with the age of this thing. There's a lot of dodging of space junk that's going on, more and more. Some of that was caused by Russian anti-satellite tests, and some of that is just other routine kind of junk that's up there. There's a micrometeorite hit that caused a loss of coolant on one of the attached Soyuz craft, so that was an area of concern. They had water accumulating in some of the spacesuits, and that was a big concern. There's now new contracts out for new spacesuits, and eventually that'll get fixed. The Boeing Starliner is the SpaceX competition in the private world for getting to the space station. They finally managed to get that working well enough to dock in one of their tests. No crew, but the next test will be with a crew. The equipment is aging, but some of it does get replaced over time. In particular, the solar arrays, which are obviously very, very important. They've started replacing them, or actually literally laying them over the old ones. The new arrays are smaller, but they're just as they're much more efficient, so they generate just as much power. So the U.S. says the ISS is probably good till 2030, and at that point, probably have to consider deorbiting it. We hope that by that time, Axiom and other space station add-ons to the station can simply detach and continue. The Chinese space station is now in full operation. The third module was added on October 31st, and that defined the end of their phase one. So it's complete and it's occupied. Um, they have annoyed people continually on their launches because the boosters that get this heavy equipment up there fall uncontrolled, and there's always a possibility of damage back on Earth. So far, nobody has been harmed. The capacity is total of 6 crew, and that has been tested now because they previously had a crew of 3 and they set up a new crew, so there's an overlap period. So there's 6 people there total. The station has about a fifth the mass of the International Space Station. Now, one interesting thing is that this will be expanded in the future, and it's going to be joined by a more powerful version of the Hubble telescope. It'll have a comparable resolution as an optical telescope, but it will cover a much wider angle of the sky in one picture. It's simply newer technology. And it is interesting that they're going to place it in a co-orbit that is very, very close to this space station, so that if there's any maintenance required, it's a short spacewalk away. That seems like a pretty good idea. This was a big year for the large constellations of satellites that are providing internet service. The biggest of all is the SpaceX Starlink service. It has the 3,200 satellites up there now. 1,700 of those were launched in this last year, and it now has 1 million subscribers, so it has been growing. Um, they they had one unfortunate incident proving that space weather really matters. In one of their launches, they lost 40 satellites after the launch. This happened back in February. There was a big solar flare, a geomagnetic storm, and that ended up increasing the atmosphere size, and hence there was increased drag. And as a result, those satellites they were not able to, power up to the higher orbit. Normally, they go to a low orbit and then go up from there on their own power. But they couldn't do it. They couldn't overcome the drag, so they lost 40 satellites. They now are launching to slightly higher orbits, and they're paying a lot more attention to space weather as well. The other big internet service provider here is OneWeb. They haven't actually opened commercial service yet. That'll be coming fairly soon. They now have 502 satellites up there. 110 of those were launched in 2022. They were affected quite a bit and slowed down by the Russian problems because all of their launches had been on the Russian Soyuz craft. Now they've contracted with SpaceX, which is a direct competitor, and also the Indian uh, government, really, for the government's launches there. They're doing that instead of the Russian Soyuz craft. One concern, of course, has been raised by astronomers. They're afraid that all of their pictures now are having streaks due to all the satellites that are up there, and there's more and more of them. SpaceX had made quite a bit of an effort to try to at least reduce the impact of that. Maybe OneWeb has as well, but it's still a concern. The elephant that's not in the room yet is Amazon's Kuiper project, which is also intended to provide internet service from satellites. It's been estimated to cost about $10 billion, but its service really is still years away. Part of the problem is that no prototypes have even flown at all. First, they were waiting for ABL's RS-1 rocket. That's a new space company. They were going to go up in that. They got delayed, and Amazon got anxious, so now they've hedged their bets and going with the United Launch Alliance's Vulcan Centaur, which also hasn't flown yet. So fairly soon, sometime in 2023, we will see their prototypes go up, but that's got to hurt. Now there's time pressure. When they get their license, the FCC licenses satellites, and it required that half of their satellites, which is over 1,600, have to be in orbit by 2026, and the other 1,600 would have to be in place by 2029. So they have a rather tight time schedule to get all those satellites up there and a working service when they haven't even tried it out yet. Now they're trying to catch up. They put in a big effort. They're booking in 2022. They booked 83 launches. That's a pretty large number. People have guessed that maybe that's about a $5 billion kind of set of contracts, but nobody really knows. The interesting thing is that all those contracts are on rockets that don't actually fly yet. 38 of them are on the Vulcan Centaur, which is for United Launch Alliance and hasn't flown yet, partially held up, ironically enough, by the Blue Origin engines, which are owned by Jeff Bezos also. So they're contracting 38 on the Vulcan Centaur, 12 launches from Blue Origin with an option for 15 more, and that's on their New Glenn rocket. and then also 18 from the Ariane Space Europeans, the Ariane 6, but the Ariane 6 doesn't fly yet either. Now, those 83 launches don't count ones they had previously booked. They had 9 booked on Atlas V. Those are, just being used up over time. They're not making any new ones, so they're already purchased. Anyway, what's happened though is that because all these rockets don't yet fly, of course now they get pricing pressure, but they get a potential huge customer. So they're really in effect driving the rocket development on everybody except SpaceX. They were just not going to go with SpaceX. There are other satellite constellations that are growing. One interesting one is direct communications between ordinary cell phones and satellites. Not the Iridium style, which was special bands. This is actually ordinary cell phones. It's starting kind of. And Apple really was the first to get to commercial service with this, specifically just for emergency messaging. Actually, they've already saved a life. Someone ran off a road and communicated with a satellite and where there was no other cell phone reception. Apple is investing very heavily in Globalstar for the satellites here. In particular, they're investing in the ground stations. Globalstar is pretty small. They only have 24 satellites. They have said that they will dedicate 85% of their capacity to Apple. And mainly they took a lot of new ground station investment. That's where Apple's putting in the money. It doesn't seem like this is really going to be much of a long-term solution, so without a whole lot more satellites somewhere. So what Apple will do long-term is not known yet. Now, there are other players in this field. The first two really were AST Space Mobile and Link. AST Space Mobile seems like it's the most likely to have a good technical solution. They simply use a giant antenna, 26 by 26 feet, in their prototype. And that's shown in the lower right corner here. Their final satellites will be even quite a bit bigger than that. They have gotten their one of their test satellites up, and they have been testing this. So it's a proven ability. It just needs to be worked out. Link is the other one that was probably the biggest in this business. They've been testing text messages now for a couple of years. They have 4 satellites up there. Their goal is thousands of satellites, and they hope to get eventually to voice service. But in the short term, it's mainly going to be emergency use, text, maybe very small amounts of low resolution pictures, that kind of thing. The bandwidth simply won't be there yet. The other big player to walk into this, though, is SpaceX. They've announced a deal with T-Mobile. All this happened in 2022. They're starting off just handling text, nothing else. And what they're doing is they're going to add a 16 by 16 foot antenna to their version 2 Starlink satellites. Now, they haven't gotten the version 2 Starlink satellites up yet because they're really waiting for Starship to be big enough to actually handle those larger satellites. So that's not happening yet, but that's all coming eventually. Now, there are other satellite constellations here. The big ones are for Earth observation satellites, and there's a lot of companies involved in this. They're growing, and most of them are approaching profitability, or at least have the ability to do it within the next few years. For instance, Planet Labs, they have over 200 satellites in their constellation of Earth observation satellites. Others in this business include Black Sky and Maxar. Maxar is getting bought out. They actually are slightly profitable at this point. Other players are ICEYE and Capella. They are doing synthetic aperture radar, so they can penetrate the clouds. So for military purposes in particular, you can see what's going on even if there's cloud cover, unlike the optical satellites. The picture on the left here, and this one happens to be from Maxar, kind of illustrates, though, the kind of business they're going for. It's not all military and not all spy. If you just want to analyze what companies are growing, you look at things like how many cars are in their parking lot. And what these people are offering is the ability to go over the same location and do it many times a day, take the pictures, but not just take pictures, use machine intelligence to analyze the pictures and look for differences. Well, one, recognize the objects like cars. Another is to look for differences from time to time. And that's kind of illustrated by this changing picture down here showing different times of the day or different months, what activity is going on. So there's a lot more in combining image analysis, artificial intelligence with the basics of just taking pictures, and they're having more and more satellites to do that. The Planet Labs satellites are very small. We're talking CubeSat kind of size. Some of the other ones, Black Sky and Maxar, are more traditional and bigger. NASA and other government agencies do get involved in research on enabling technologies. And a couple examples of those are one is the inflatable heat shield called Loft ID, and this was done. It was actually demonstrated in returning from Earth, from orbit back to Earth. Put up a large shield, even much larger than the diameter of the rocket, which they haven't done in the past because they're inflatable. And there's a picture of this shown here on the right, and the final ones will probably be quite a bit bigger than that. The reason for doing this is simply that you get much more braking ability, or you want to slow down when you go into an atmosphere. That'll be especially important on Mars, where the atmosphere is so thin. And also, it could end up being quite important on Earth because it means that you could land much more cheaply. So, for instance, if you ever want to manufacture or import anything from space, it costs you a lot to get it back down to Earth. And if you can just have that using a fairly inexpensive inflatable shield, it's going to improve the economics quite a bit. Another example of research, it really started in 2021 on Mars on the Perseverance rover, a project called MOXIE. What it does is it extracts oxygen from the Mars atmosphere through a chemical reaction, solid oxide electrolysis. You take a couple of molecules of CO2 and you split it into carbon monoxide and oxygen. And of course, that would be needed for breathing purposes, as well as making rocket fuel for return trips. So they started in 2021, but then they ran tests over and over again at various different combinations, high and low pressure, summer, winter, night and day, all those kinds of things. And they've concluded that under almost any conditions that they're going to encounter on Mars, with that 95% CO2 atmosphere, they can indeed extract O2. And they've think they have some ways of scaling this up for larger use. This was just a prototype, but they've been doing it. And this is really the first demonstration of in situ resource utilization on another planetary body. It just hadn't been done before. And there's a lot of small projects like that going on, not enough. And unfortunately, NASA just funds a lot of this. They aren't necessarily putting it in the main projects, but they, in some ways they can't, because they don't know if those things are going to work. But more and more of these things are starting to get started, and hopefully will play out to make it easier to go to other planets and not have to import everything. So that concludes the summary of space activities in 2022. It really was an exciting year, and 2023 promises to be even more exciting, in particular with all the missions headed to the moon. Are there any questions or comments at this time?